An estimate of the fish population was found by catching 100 fish and marking and returning them to the pond. The next day, 400 fish were caught, of which 10 had been marked the previous day. Estimate the fish population of the pond. Okay, this is a famous method that is actually used by biologists to count the number of fish in a lake. It's also used to count the number of deer on a mountain or the number of rabbits in a field. So this is a biological method used to count animals very often. So how does it work? It's basically called the capture-recapture method. Let me, I don't want to just tell you the formula and crank it out. I will do that. I will get to that. But I want you to feel it first off. I want you to see it's true. Just think with me for a second. What if I told you, let me make the numbers nice. What if I said that they catch 50 and tag them? Suppose we catch 50 fish and tag them. Then release. Then release them. So we catch, tag, and release. So step one, catch them. Step two, a few days later, giving them a chance to all kind of mix around. A few days later, recapture at random with a big old net. You just throw down a net, recapture at random. Let's say 20 fish, and you look at them and notice 10 have tags. 10 are the ones that you tagged on the previous day. You recognize they've already got the tags from the previous day. So think with me real life. I think you'll sense what's going on here. And the question is, can we, step 3, estimate the total number of fish in the lake? This is how they do it, because it's too hard to, how else are you going to count the total number of fish in a lake? Even with technology, with sonar and stuff, they're always moving around. You're not going to be able to do it. And there's different kinds of fish. What if you wanted to count just the number of trout or just the number of bass? They all look the same on a sonar from up above. You have to, this is the method actually this is a current state of technology. It has been for a long time for biologists to count animals of all kinds. So how could you estimate the total number of fish in the lake? Well, think with me. Think specifically about this recapture stuff. A few days later, we recaptured at random. This is where the probability comes in. It's a probability idea. We captured 20 fish just at random. We just randomly threw down a net, pulled up 20 fish, and we looked at them and we say, hey, 10 of them are the fish we tagged a few days ago. So in other words, in your random grab of 20 fish, 10 of them are tagged fish. 10 out of, here, let me move it. Over here. 10 out of 20 are tagged fish, which means you're thinking probably about half the lake is tagged fish, right? You just grabbed 20 fish at random, and it turned out 10 of them had tags from the previous few days. So just a random grab of 20 fish, 10 had tags, half of your group had tags, right? 10 out of 20, probably about half of the whole lake has tags, because this was just a random grab of fish. So if half of your grab had tags, probably that's representative of the whole lake. Probably about half of the whole lake is tagged fish. So do you understand that point? That's the key. So you grabbed, a few days later, you grabbed 20 fish at random. 10 out of 20 happened to have tags. So you're thinking, oh, about half my group that I grabbed at random has tags. Probably about half the whole lake has tags. Well, so this is half the whole lake. Half of my sample. This is half of my sample. So we're thinking it's half the sample, so probably half the lake has tags. Half the lake has tags. Half of my sample has tags, probably half of the lake has tags. So if that is the case, that half of the lake has tags, then you know how many have tags because you did it a couple days ago. You put 50. 50 have tags, right? 50 have tags. And so how many fish would that give? If half of the lake has tags and you know there's 50 fish in the lake that has tags because you did it a few days ago. If half of the lake has tags and you know 50 have tags, how many in the lake? Number in the lake must be 50 times 2 must be about 100 fish in the lake. Make sense? See how we're able to estimate? Because you know about half of the lake has tags because you grabbed 20 and 10 of them had tags, so about half the lake has tags. You know 50 have tags because you did it a couple days ago. So that's got to be half the lake, so that means there's got to be about 100 in the lake. There's about 100 fish in the lake. Do you see how we're able to just use logic and probability in the sense that we grabbed half the lake and that fraction is probably about the same as the portion for the whole lake. It's very likely. The official math you would do is you would actually set it equal to 50 over x. I know you could just figure it out in your head and just multiply by 2, but the numbers are going to be harder in general here in a minute, and so we're going to want a method. You would just put this over x, and what we do is we call this tag over total is tag over total, right? There were 10, well, originally we tagged 50, and we want to know the total number of fish in the lake. And on the recapture, we found 10 tagged out of 20. So it's tag over total, and then you cross multiply. So 50 times 20 is 10 times x, right? 10 times x, 50 times 20. So that's what? That's 1,000 is 10x. How do you solve for x? Divide by 10. There it is. X is 100, just like we kind of intuitively knew. There's about 100 fish in the lake. So that's the idea. It's called the capture-recapture method. It's logical. Let's go back and do it on this particular problem. So the key formula on these fish problems is tag over total and tag over total. For the capture phase, so we start with the capture phase, and then we end with the recapture. So in the capture, in the first capture, start with 100. We catch 100 fish, and an estimate of fish was found by catching 100 fish and marking and returning them. So those are tagged fish. So that goes in the top because that's tagged fish. Equal. And then the next day, so let the fish swim around and mix it up, 400 were caught, of which 10 had been marked the previous day. 10 were tagged fish out of 400 total that were recaptured. So this is my x down here, the total in the lake. So now let's solve that. Cross multiply. 100 times 400 is 10 times x. So 100 times 400, you just do the 400 and you just add the 2 zeros at the back, right? The 2 zeros from the 100 go to the back, so that's 40,000 is 10x. And then you finish solving this thing, divide by 10 on both sides. That just cuts off a 0. So 4,000 fish. So our estimate is that there's about 4,000 fish in the lake.